Hello, everyone. My name is Thomas Gerber, and today we'll talk about how open source communities shape modern data stacks using what we've built at Pharos as an example. So what did we build in Pharos? We decided to build a data infrastructure for software engineering operations. That means that we collect, normalize, and connect data from various software engineering systems, such as Jira, GitLab, PagerDuty, or CircleCI. And we put all the data in one place where users and customers can leverage it for analytics, like, for example, building DORA metrics for those familiar with DevOps, or automation, reminding you that you have a PR to review if you haven't reviewed it fast enough. So we started by crafting this data schema that models software engineering from pull requests to incident. And then we went on trying to figure out how to architect our product, especially the data stack. And obviously, one of the first challenges we faced was to figure out how to do data ingestion. We knew that we required ELT, extract, load, transform, and we knew that data movement is hard, and we didn't want to reinvent the wheel and focus our energy on solving ELT problems. We wanted to focus on those analytics and automation experiences I was mentioning before. So we knew we were going to look for an ELT platform. But also, because we are a data infrastructure, we knew that flexibility, extensibility, and security were critical capabilities of that platform. And so, interestingly, open source software shares those values of flexibility, extensibility, and security just by the nature of open source code. So we decided to not just look at ELT platforms at large, but we decided to look at open source ELT platforms. And this is obviously how we came across Airbyte. A few things stood out immediately with Airbyte. First, the community. Just using my own tool, I loaded the main repo in GitHub in our tool and charted a few things. If you look at PRs and committers on a weekly basis, you see that there is well over 100 PRs being merged every week by over 50 different committers. This gave us the confidence that Airbyte was very active, was here to stay, and that we could build upon it. The second thing that stood out was the Airbyte protocol. We knew that we would have to build a lot of sources to various software engineering systems, and even our customers may have data we're interested in homegrown systems, right? And so we wanted to make sure that Airbyte was flexible enough to accommodate our customers, to let them extract their own data to put it into Pharos, regardless of where it was. And the Airbyte protocol was a perfect fit. And finally, the third thing that stood out was the catalog. First off, the fact that it's so large validates the protocol. And then there were a few sources that we were interested in, specifically Jira and GitHub. And the fact that they were already there allowed us to get prototyping immediately. And so we gave it a go and integrated Airbyte into Pharos. So what does it mean to integrate Airbyte into a product? It means three things. We built a Pharos destination. After all, that's where the data is going, right? So what is a Pharos destination? It's a set of small converters that read streams from sources, read those entities, and map them into our canonical representation, meaning on our data schema. So for example, here, I loaded a converter for the merge request stream from GitLab source. And those merge requests in our data model, it's called a pull request. And so the converters just write that down. We have converters for every stream we care about, for every source we care about. They're pretty short, so easy to create and to maintain. That was the first thing we did. Then we had to figure out how to deploy Airbyte in Pharos or alongside Pharos. And we needed some things that would work both for our SaaS offering, but also on-prem. Turns out Airbyte is container-based. There is a Docker Compose in the main repo. not a problem. There was everything we needed there. And finally, we wanted to make it as simple as possible for our users and customers to set up data ingestion from their systems into Pharos. And so we exported a golden, we exported a golden version of the Airbyte config. Some of you may have used this feature. Sorry, I just need to finagle with the controls here. Yeah. For those who have used it, you can see that it creates a bunch of files that represents your Airbyte config. And we versioned it. And then we created a script that would import it into the Airbyte instance that's being deployed with your Pharos instance, so that all those sources we care about are automatically there, automatically connected to the Pharos destination with all the streams properly set up, right? That means that the users only need to provide the config that is specific to them, especially the API token, and they're good to go. So yeah, that was the extent of our initial integration. Pretty straightforward, pretty quick as well. And then, we started giving back, contributing back to the community, to the Airbyte project. One of our employees here at Pharos is actually a maintainer of the project. And some of the things we built that we contributed back include the TypeScript CDK, Connector Development Kit. We're a TypeScript shop. We knew we were going to build a lot of sources. So, we take some time to build the kit as well, and contributed it back, as well as a few sources, Harness, PagerDuty, Jenkins, and so forth. It's a win-win. The community is richer for those tools and sources, and also now the community can help maintain and improve those. And so what I described here specifically for the data ingestion part of our stack for a product, we applied the same principle for everything else. So we chose dbt to persist and compute metrics. We picked Metabase for the BI layer. I just showed you before with those PR stats. We chose Hasura for the GraphQL API and Postgres for the database. And a very interesting side effect of having open source projects as your main components for your data stack is that it became trivial for us to now open source Pharos itself. You can check it out on GitHub, Pharos-community-edition. And what's interesting about it, if you look at the actual repo, it's just the schema I was talking about since the beginning. And so that's a bunch of SQL. And the init scripts and config that I also mentioned, for example, the default dashboard in Metabase or the Airbyte config. And that's it. That's all it is. And so to sum it up, the flexibility, extensibility, and security of open source code gives you the focus you need to ship your core value. Easy things will be easy. Hard things will be possible. But the data stack is not going to prevent you from achieving anything. Those open source projects are also becoming industry standards, right? Some of them at least, Airbyte, dbt. And so they're becoming easier and easier to compose and integrate with each other and with the rest of your stack and product. So you get the speed. And finally, you get alignment. Any improvements to those projects, whether it's contributed by yourself or by the community, lifts all the boats. Meaning, if someone ships a bug fix for the GitHub source, say, we benefit from it. Our customers benefit from it. Everyone else in the community benefits from it. And you are also incentivized to contribute, because if you contribute a feature or a source, in the case of Airbyte, now the community will help you maintain and improve it if it's useful. So focus, speed, and alignment. And that is why I think that open source communities shape modern data stack. Thank you so much for listening to my talk, and I hope this encourages you to check out some OSS projects or open source projects for your stack components, and that I hope that you contribute back to those communities. Thank you so much. Again, I'm Thomas from Pharos, and I wish you a great conference.